Hello everyone and welcome back. In this video, we are going to learn how to simplify problems where we are dividing numbers with exponents. Before you get started with this video, you should understand the fundamentals of exponents. For example, if I give you a number like 3 squared, you should know that that's 3 times 3. And if I gave you an example where we have to multiply numbers with exponents like 3 to the power 4 times 3 to the power 3, you should know that you're going to add those to get 3 to the power 7. If this is a new concept to you, check out some of the links in the description that'll help you review and understand these basics before you move on to division. So let's talk about division with exponents. This can be written in a lot of ways. It can be written as 3 to the power 3 divided by 3 to the power 1. It can be written as 3 over 3 to the power of 1, and it can even be written as a multiplication problem as 3 to the power 3 times 3 to the power negative 1. In any event, we'll walk through how to solve each of these problems. But first, let's talk about some fundamentals of exponents. Primarily negative exponents. Whenever you're given a negative exponent, you can think of that as division or as a fraction, because if you have a negative exponent, you can find the reciprocal or you can flip it, and that will give you the same thing. For example, if I gave you 4 to the power of negative 2, you could rewrite that as 1 over 4 to the power of positive 2. This also works backwards as well. I could give you something like 1 over 5 to the negative 2, and you could rewrite that as 5 to the power of positive 2, because you just move it to the other side of the fraction. All right, let's look at a couple problems. For part A, we have 4 to the power of 2 divided by 4 to the power of 3. Whenever you have this division symbol, I recommend rewriting it as a fraction bar. So we have 4 to the power of 2 over 4 to the power of 3. Now there's a couple ways we can do this. You can know that when fractions are divided, you subtract, kind of the opposite of multiplication causing exponents to add, or you can expand it fully. We'll do it both ways here to prove to you that it works. On top, we have 4 to the power of 2, which is the same thing as 4 times 4. On the bottom, we have 4 to the power 3, which is the same thing as 4 times 4 times 4. Now we can do some canceling. 4 and 4, 4 and 4. So this leaves us with 1 over 4. Okay. Before starting this example, we talked about how we can flip fractions and make exponents negative. So we know that 1 over 4 is the same thing as 1 over 4 to the power of 1. If we want to flip it and bring the 4 to the top, that's the same thing as 4 to negative 1. So these are both the same thing. Now, instead of writing all this out, I told you we could do subtraction. Let's look at the first way I wrote this problem, and let's rewrite it as a multiplication problem. So in front, we have 4 squared times 1 over 4 to the power of 3. We know this is true because the division symbol tells us that it goes on the bottom, and this is just another way to rewrite a division problem as multiplication. Okay, let's rewrite it one more time, changing the 1 over 4 cubed into a negative exponent. So we have 4 squared times 4 to the negative 3. All of these are the same. I just showed a whole bunch of steps to get there. In general, you can take this division symbol, make this exponent opposite of whatever it is. So if it's a 3, you make it a negative 3. If it was a negative 5, you would make it a positive 5. And that would then give us what we have on the right-hand side here. Now we are simply multiplying numbers with exponents. So from our previous videos, we know we add the exponents. 2 plus a negative 3 is the same thing as 2 minus 3. So this gives us a final answer of 4 to the negative 1. Lo and behold, that matches the previous problem, or the previous example. Another way to approach this problem is to use a similar method as 4 squared over 4 cubed, but instead of expanding, we are going to simplify the exponents without doing all the crossing out. We will start with 4 squared over 4 to the third, and you can see that there is 2 on the top, 3 on the bottom. One way I like to think about this problem is I'm going to compare the top exponent, which is 2, to the bottom exponent, which is 3. And I'm going to try and figure out which one is stronger. In this case, 3 is stronger than 2 because it's the bigger number. And how much is it bigger than 2 by? 1. So, once it's all said and done, there will be an extra 1 in the exponent on the bottom because 3 was the bigger and stronger exponent. In math terms, we're going to look at 2 minus the 3 or 3 minus the 2. It doesn't matter how you look at it, just know that the leftovers always go on the winning side. So the 3 on the bottom minus the 2 on the top leaves you with 1 left over, 4 to the power 1. And the losing side, which had no exponents left, becomes a 1. And of course, this simplifies to 4 to the negative 1, which is exactly the same as all 2 of our other solutions. So there are a ton of ways to look at these problems. All of them work. It just depends on what works best for you. Looking at part B, we have a multiplication problem that is actually division. Like we learned from the previous example, 5 to power 6 times 5 to power negative 3 is going to be multiplying numbers with exponents. Since our bases are the same, that remains unchanged. Now we have to look at the exponents. Since it's a multiplication problem, we add the exponents. 6 plus negative 3 is the same thing as 6 minus 3, which is going to give us 3. 5 to power 3 is our final answer. A different way we could have written this is it could have been 5 to power 6, and we move the 5 to power negative 3 to the bottom and make the exponent positive. So we have 5 to power 6 over 5 to power 3. We're going to subtract those exponents from each other, or in other words, we're going to see which exponent is stronger. You can see that the 6 is stronger than the 3, so we will be left over with 5 on the top, and 6 minus 3 leaves us with 3 left over, and the one that lost is a 1. So 5 to power 3 over 1 is the same thing as 5 to power 3. So those are 2 quick ways to simplify this problem. Let's move on. Taking a look at part C, this should be something you now understand how to solve, so go ahead and pause this video and give it a try on your own. For the solution, we will start off by writing our problem, and we will use the same method that we ended with before. So we're going to compare the top and bottom exponents. The 3 is larger than the 2. 3 minus 2 gives us a 1 left over. So we have 7 to power 1 on top. The bottom exponent lost, so that just becomes a 1. And that's our final answer, 7 to power 1. All right, let's move on to part D. In this part, we have to do a little bit more work. The first thing you may notice is that our bases are not the same. So in our previous videos, we've learned how to convert numbers with different bases into numbers with the same base. Let's review that now. If we have 8 to power 1, we can rewrite that as 2 times 4 all to the power of 1, and we will rewrite that one more time as 2 times 2 times 2, still all to the power of 1. Now you see in here that you have 2 times 2 times 2 3 times, so that becomes 2 to the power of 3, and of course we still have that power 1 on the outside of the parentheses. For our last step, we have an exponent inside a parentheses and an exponent outside the parentheses. When we have that, we should multiply the exponents together. And in this case, 3 times 1 is still just 3. So we simplify this to 2 to power 3. Okay, so we addressed the 8 to power 1 right here. Now let's address the 4 to power negative 2. We can do that in orange. 4 to power negative 2. To get started, we put the parentheses, the negative 2 stays on the outside, and then 4 can be rewritten as 2 times 2. Again, we notice that 2 times 2 can be rewritten in exponent form, so that will look like 2 to power 2, and the outside of the parentheses is a negative 2 in the exponents. Again, you've got an exponent inside and outside the parentheses, so we have to multiply those together. So our final simplification in this step is going to be 2 to power 2 times negative 2, which is a negative 4 in the exponent. Okay, that is the middle part of part D. Now let's put it all together. We can rewrite this in blue. We have 2 to power 3 times 2 to power negative 4, and 2 to power 3 again from the 8 to power 1. To simplify this, we have numbers with the same base and multiplication. Therefore, we add all 3 of the exponents together. 3 minus 4 plus 3 gives us a positive 2. So our final answer will be a base of 2. That's unchanged. And adding all the exponents together gives us a positive 2. And that's your final answer. Okay, so that was a lot. We'll slow it down a little bit here for part E, but essentially it's the exact same type of problem, now we just have different numbers. We have some numbers that share a base of 3, or 9, which we know we will convert to 3, and then another group of numbers that have the bases of 2, or which we will convert to a base of 2. Let's get started with 4 to power 2 and 8 to power negative 1. 4 to power 2 can be rewritten as 2 times 2, all to that power of 2, which simplifies to 2 to the power of 2, and again parentheses power of 2. Multiplying those exponents together gives us 2 to power 4. Okay, so this one is handled. Now let's look at 8 to power negative 1. We'll skip a step because we know that 8 is the same thing as 2 times 2 times 2, all to the negative 1. Rewriting 2 times 2 times 2, we get 2 to the power of 3, all to the negative 1. Now when we multiply those exponents together, we get 2 to the power of negative 3. All right, now that's handled. Let's put a circle around these in blue so we don't forget about them. Okay, let's take a look at 3 squared. 3 squared is actually good as it is, so we will leave it alone because that's as simple as the base can get. And now here's the tricky part. We have divided by 9. So either we can put the 9 on the bottom and have a big fraction, or we can convert 9 to the power of positive 1 to 9 to the power of negative 1, and we will flip the division symbol around. Let's do the latter option. So we will rewrite this as everything times 9 to the power of negative 1. This will keep it simpler as we move forward. Rewriting 9 to the power of negative 1, that's equal to the same thing as 3 times 3, all to the power of, let's curve that, negative 1. So we have 3 squared on the inside, negative 1 on the outside. 2 times negative 1 in the exponent gives us 3 to the negative 2. All right, there we go. Now let's rewrite this in one big long line. We have 3 squared times 2 to power 4, that's this first one here, Then we have multiplied 2 to the power negative 3. That's the second one here. And then lastly, we have 3 to negative 2. All we have done is rewritten this problem to make the bases match as closely as possible. All right, now let's focus on the ones that match. Let's look at 2 to the power of 4 times 2 to the power of negative 3. When these are multiplied together, we will subtract the exponents. So 4 minus 3 leaves us with 1 in the exponent and a base of 2. Okay, so that's the yellow part. Now we need to look at the reddish orange. We have 3 to power 2 times 3 to power negative 2. Again, adding those exponents, we get 2 minus 2, which is the same thing as 0. So we have 3 to power 0. And you should know that anything to power 0 is 1. So we cross this out, put a 1 here, and 2 to power 1 times 1 is simply 2. And that is your final answer for this problem. Great. We have covered a lot in this video. Understand that Part D and Part E were very complicated and there were multiple steps. Ultimately, all you truly need to understand is how to do A, B, and C. Those problems cover the fundamentals of dividing exponents and manipulating negative exponents. Once you've mastered that topic, you'll be able to apply it to problems like D and E. Hopefully you learned something today. Thank you so much for watching, and if you have questions, feel free to drop them in the comments.